they're not the holes in the leaves.
Okay,
They're the
that's a
deflated galls.
That's what we call the little black rings. So then we.
Okay?
So all of the galls, yeah, 2, 4, 6, 6 galls, once you count that. All of them,
Oh, that might be fine.
so all of the galls, also, all but one, created new organisms, cause they have escape holes.
All right. Mary Lou, y'all about ready?
No, because she, can't handle the fact of not doing as a rectangle, leaving that it's not correct, so she has to find the shaded area, and that takes a few minutes.
I would do that too.
Are you doing calculus over
She
there?
likes
She's doing a lot of math that I don't
precision.
get. And I'm the recorder, so I'm just waiting until it's recorded.
All right, well, we're gonna go ahead and discuss what's up here already. So, is that your little thing? I don't know how to do your little,
The button on the right.
is the light?
To the power of.
Oh, the lights in the front.
Okay. All right, thank you. So right here, this is talking about the area of the leaves, I think, what we decided last night. So this is the area of the leaves without anything. And here is the area of the leaves with scars but no galls still full on there, okay? So, these are all areas, correct? To the nearest, 10,000. All right. So, I don't think we're going to do anything with this column right here. We're only going to look at these two. Tell me if I'm wrong, Sam.
Yes, we're only gonna look at, with galls, leaves with
Okay.
galls or not galls.
Alright, so here is, the area of the leaves with galls, the mean, the average. And here is the average, the mean of the leaves, of the area of the leaves with no galls. We're not gonna worry about these. Scars only, okay? So this is the formula that you would use to run this t-test here. T-test. So the formula is, Tim, can you see that to read it? This is a what letter?
T.
T,
T, can you read this?
obtain.
T
T,
obtain,
and it is OBT, so which is obtain.
okay,
Equals
so this is the,
mean of x1
okay, and,
minus the mean of x2
good, over,
over the square root of, what is that, s sub 1 squared
good,
plus, oh, sorry, s sub 1 squared divided by n1, n sub 1,
good,
plus s sub 2 squared divided by n sub 2.
good. So it's a complicated formula, but all of these numbers that you would need are in this, chart, all right? So here's, the variance, there is, standard deviation is the S, so this would be S sub 1, S sub 2, and the N, Sandra, where's the N? I lost it. Oh, sample size right here, which is 19, so that's N sub 1, and that's N sub 2. Okay? So Sandra and I worked this out last night, and we averaged it, we rounded it,
We
and
did an
so
Aggie version.
we did the Aggie version. And so we got the, T here to be 2 1400ths.
And we'll show them how we did it.
2
Give me those
1400ths.
numbers.
Alright, let me put my glasses on then. So we used a 9 for the mean of x1 and 6 for the mean of x2 over square root of. And the square of s sub 1 is 36. And the n, so that 36 is over sub 1, which is 19. And the square of S sub 2 is 16 over 169, which is the n of the n2. Okay? And we got 2 and 1400ths.
And the analysis that they got, go to the next slide.
So they have 155 degrees of freedom, and the standard error of difference was 1 in 39 hundredths. So the 2 and 1400ths is greater than 1 10 thousandths. So the p-value is not significant, so you reject you keep the null hypothesis.
Or fail to reject the null hypothesis, i.e. keep.
Yeah, fail to reject
That
it.
makes sense.
Statisticians say things strangely, so if you fail to reject, you keep the null hypothesis.
Not giving you up so much.
So this is only one sample, and so what was the null hypothesis, do you remember?
Yeah, I was gonna say, can you go back to
The
it?
size,
Hand.
Larger
just-
leaves.
larger leaves do not have
Have
more
more
galls, the smaller leaves.
So do we,
But that doesn't match up to what the data you just showed us.
larger leaves do not have
No,
more
no,
galls than
that's
the
not what I'm
smaller
saying.
leaves.
No, the data you showed us was whether or not they have galls. It had nothing with the number of galls.
This over here, isn't this the average of the number of galls?
You said that's the area of leaves in
This is the
centimeters
area of
squared.
leaves, this is what I'm thinking, because this is not my data, so not real sure.
Yeah, it's area of leaves with galls.
That's the area
And the second group
with
is area
galls.
of leaves with no
That's the
galls.
area with
Right.
no galls. There's
So
not
if
the
it's
number.
not no galls or scars, it can't be a count of galls. It's still area.
Okay, and I agree with you.
Okay, I don't.
It's not my data, so I really
No, I-
don't know, who's
Alexis?
Oh, I see what he's saying, 'cause-
You wanna jump in here?
Because we're talking
Size,
about
Dr.
n
Noble.
versus the number.
Because
of
we're talking about the
galls.
size of the
There it
leaf
is.
versus
Hang on
number
now,
of galls.
Alexis is speaking.
Okay, here, can we move to the slide with the integrity data on it?
This one?
No.
The one, this one,
No.
Two more.
back or forward?
Forward.
Two.
Alright.
Okay, so down here, what it says is in this one sample, leaves with galls were not larger than leaves without galls. If we go back to our null, that's kind of what we were
That's-
saying here.
right.
So,
But that wasn't his question, so go back to that next slide.
Mine is saying that's a count of galls versus that's just whether or not they have galls. That's different.
Yeah,
so the alternative hypothesis is different, but the null hypothesis is maintained because there was no significant difference in the presence of, or the presence or absence of galls correlated to the size of the leaf. So the problem that you're having is with the alternative hypothesis.
But I was saying, how does your data support that if you don't count the number of galls?
The data does not support that. The data supports the null hypothesis, which is that there is no difference.
Oh.
so it didn't matter how many galls they had on it.
Whether they
If they
had
had
galls
one
or
or
not.
100, it didn't matter,
That's
it's
for
just
the
the area
null.
of that leaf,
Yeah.
You're looking at something.
I think.
The null is just whether they have galls or not.
Right. Not how many galls, yes ma'am.
If we were gonna, I'm just thinking now about like doing something like this in the classroom, might be helpful to have, leaves without galls
Right,
to do.
To show them the difference.
Because I mean, we sat here and we counted the galls, but
Right.
that never happened in that data whatsoever,
Right.
so it doesn't
Right,
correlate.
it was just
Oh,
sorting,
area.
galls, no galls.
Okay, and we can do that. Now, let me tell you just a kind of a teacher talk here. The two oak trees in the front of the greenhouse, that I couldn't find any leaves with galls on them. So I emailed Dr. Ott, whose research this is, and he told us to go to the oak tree that's down here by the dumpster. So you don't think you can suddenly find these materials. You need to make sure, you know, you've got a source, and in fact, Ruby and I were talking about collecting them, because we're gonna do this, in July with another group, and we're gonna do this with our class, about collecting specimens and making sure we've got them for next year for 2 semesters, and then another one for the summer.
Okay, so, is it making more sense, cause I
I-
can get around in my head as well.
Still not a great spot.
Okay, let's go ahead and we'll come back to this, because there's a point that we wanna make here.
Alright,
Okay,
so, the conclusion is
thank you very much. Okay, so the issue here is, what did we have in this design? You have a chart there that shows, the components. So we just looked at the experimental design on the right side, the right column, you see that? And those are the critical attributes for experimental design. And you'll notice that the row with control is the only one that has an X under it for experimental design. And so now, do we have a research question in this investigation? Yes. Do we have a hypothesis? Yes. Do we have methods? Yes. Do we have variables identified? Yes. Are the variables kept constant except the ones that we're testing? Yes. Are we collecting data? Yes. Are we doing statistical analysis? Well, kind of. Actually, we are, I guess, with numbers and leaf areas, etc. And did we get a conclusion? Yes. If there was there a control?
No.
No. And so, what kind of design is it? It's a comparative or correlational. So what you will notice is, in this middle column there, comparative is what's in the TEKS, because that's what the Texas Academy gave to us in '91. I tried to get them to change it, and they couldn't handle it. So it's still comparative, but it means correlational, and actually correlational is a better term because people understand that better. And so this one on the galls is a correlational study, and the question is there a correlation between the area of the leaf and the number of galls on it? Do bigger leaves have more galls? And there was no correlation with it. So that's the critical attributes of the comparative design. So I want to go back in a moment to look at some teacher stuff about time and cost that Rowan put together. So you heard a little bit about it from Alexis about, you know, what they did with ecology. Kim did the same thing. You can ask her questions if you like. So with the gall one, it depends on the number of leaves per team. So the more, usually the more equipment materials you have, that each student can have one, it's gonna be a better learning experience. And so it also depends on then how many number of leaves. So I artificially said, each one of you take a leaf, so you have 4 leaves in your group. And remember, the larger the data set is better. And so a lot of times when we're doing investigations, we'll take data for the whole day, every period, and you end up collecting the data. And it's very interesting to do the analysis. Let's say you just look at means. The difference between the means in period 1 versus, or any period, versus the total data for the means, and you typically are gonna see differences in it. And that's a good experience for them to understand why the larger the data set, the more likely you are going to get the quote correct answer with it. That's why you want studies to have large data sets as possible with it. With the ant experiment, that you pretty much got the idea with that, but notice that it's gonna take more than 2 periods to do it, and I think it'll take more than 2 periods to do your leaves also. But unless people, teachers, students, experience all 3 types of investigations, they're not gonna understand the difference. And you're gonna get the same problem that I had with my little 9th grader with the new species. You're gonna call it an experiment, they're gonna be looking for a control, and I have confessed my sins. There have been times before I understood it that I would have a kid that would say, "Where's the control?" And I'd go, "Oh, it must be that." I didn't know. So, you know, that's the idea, don't make that same mistake and mislead your children because you don't know. So that's why, you know, we're trying to do this here. The idea about cost, I think Rowan was, you know, looking at that from a teacher's perspective. Very, very little cost. The other thing that we wanted to do that we did not do because we hadn't identified the tree yet is we wanted to take you outside and let you collect a little stem so that you would see the leaves on a whole stem, etc. And as I said, you know, we didn't identify the tree. I will, after today, go out and look at that tree and see if we actually can cut leaves off of it, or if I'm gonna have to go from, you know, some other trees. The ladies said they went around on campus trying to find galls, and they were unable to. So again, you know, you wanna think about what kind of materials that you can easily access and replace. So we'll be looking for that, you know, so if we can take students out here during my course, then we'll do that and have them cut. Because think about it, how much better would it have been today if you'd have been able to go outside and cut limbs? But a better day, right? All right, so I think I saw lunch coming. I would like to get back to, when we come back in, I'd like to get back into a common activity called Drops on a Penny that's used or misused to teach this. So we'll probably do that pretty quickly and get back into some of these, finish up the inquiry. There's an article that I'm going to leave you with that Alexis has created a study guide to go with it, that article, that you might be able to use with your students. The investigation is on henbit. People call it a weed, but it's not really a weed. It's got, you know, a little flower, a little purple flower that goes with it. So I'm assuming that lunch is ready. So I'll walk up. And if y'all will bring your lunch back down here, I'll sit myself here and talk with you.
I think you need a collaborative time, not sitting in the